Well, Unit 6 is over. This is 6.10, by the way. This is your practice test. Oh my God, it's so exciting. First test of the third marking period. It's going to be a huge one. By the way, if you haven't tried these problems yet and stuff, you may want to try them on your own and stuff. Sorry, need more coffee. Oh, can't have enough coffee. Oh, I meant I can't have enough Dunkin' Donuts coffee. You know what I mean, Jelly Bean. Oh, that's the coolest commercial I've ever made. All right, kids, seriously, here we go. We're going to rock, we're going to roll, and we're going to get this done. Hopefully you understand it. If you don't understand it, it is imperative that you come see me. You need to make sure you know how to do these problems. It's a big test. You got to be ready for it. All right, here we go. A radioactive substance has an initial amount of 100 grams. Notice these are all 100. It really has nothing to do with the problem because that's 100. Remember, that's the initial amount. Now, here's the important part. It halves every 4 years. So, if you're writing the formula, it's going to be 100. Now, half is your growth factor. In this case, it's your decay factor. So your base is going to be 1/2 because it's decaying. So we know it can't be this one and it can't be this one. It's decaying. It's going down by half. Now it's going down by a half every 4 years. So if you just put t here, that means if t equals 1, so after 1 year, it would be at 50%. After 2 years, it would be at 25%. After so on and so forth. That's not what I want. I want it to have every 4 years. So what you need to do is you need to take the time, whatever that time is, and divide it by 4. So let's say t was equal to 4. T over 4, when this is 4, is just equal to 1. And they say, 1/2 every 4 years. If t was equal to 8, then you'd have 8 divided by 4, which would be 2. And you'd say, a second half. So anytime it tells you it's going to do something every couple of years, that's when we have to divide by that value. That problem was exciting. So exciting, I need some more coffee. Current population is 10,000 dollars. Not 10,000 dollars, 10,000 people. Notice, these are all 10,000. And we are increasing by 20%. This is growth. Now, you need to remember as a good student that when you talk about growth, this number in this parenthesis, this base has to be bigger than 1. So you can either put 1 plus 0.20 in here. That's your 20%. Or you can put 1.20. You need to be able to see and do both, or be able to recognize both, that these are equivalent statements. So, that's an 80% increase. This is decay, and this is decay. So we only have one choice, kids. It has to be this one, growth. And it's happening every year, each year, so we're not dividing by anything. Oh my gosh. All right, let me do one more, and then we'll take a little break. Robert invests $800. Notice, I mean, so far, so good. I've given you all the initial amount. You know that number in front is the principal or initial amount. In an account at 1% interest compounded annually. So you need to know that principal 1 plus rate to the t, compounded annually. We're not dividing by any months. We're not doing any of that crap. So 800. 1 plus. Now, here's the tricky part, kids. 1.8%. 18% is equal to 0.18. So 1.8% is equal to 0.018. Now, come test day, if you're struggling with this, grab your calculator and say, okay, I want to know what 1.8% is. So you take 1.8 and you divide by, I haven't gotten a calculator. You take 1.8 and you divide by 100. And they said, okay, I'm going to use 0.018, because that's some of the tricky part. 0.018 to the t. Now notice what I did here. All of these have varying degrees. Oh, in this case it's 3. Varying degrees of percentages, right? 0.18, that's 18%. 0.18, that's 18%. This is subtraction, decay. This is addition, growth. Subtraction, decay, addition, growth. And notice now I got 0.18. So there's my answer, choice 4. Hopefully you're doing okay. I need to take a break. Oh yeah, some good coffee. Anyway, I was having issues with my sound. I think I fixed it. Let's get back to work. Is this thing recording? Can you hear me now? Can you hear me now? That's so stupid. Anyway, let's go. Crystal was given $3,000. Man, I've been so nice to you. I've been giving you all these. Wait till the end. It's not going to be that easy. Yes, I cut my head shaving. Sorry. Anyway, when she turned 2 years old, that's kind of important in this problem. You'll see why in a second. Her parents invested at 2% interest compounded annually. So again, that's going to be principal 1 plus. Now, if you're investing in a bank and it's earning interest, it's going to be growth, not decay, plus rate to the time. So, started with $3,000. 1 plus, now 2%, if you divide by 100. Remember, anything less than 1 is going to be 0.0 something. So in this case, it's 0.02. That's 2%. Because if you multiply by 100, you'd get 2. So plus 0.02. Now here's the tricky part. I want to know when she turns 18. Wow, from 2 to 18 is actually 16 years. Don't be the trained monkey that just types in numbers and say, oh, I see 18, I see 18, I see 18, there we go. Right? So be careful. It's from 2 to 18, which was 16 years. Okay, moving on. Mr. Smith invested compounded annually again, so we're looking for a 3% increase, so we take 2,500. We're going to take 1 plus 0.03. Again, I'm just getting you used to those decimals. Really understand how to convert those decimals so that or those percentages to decimals. He made no additional deposit to all account at the end of 4 years. Wow, this is just put a 4 there. Let's see what we got. So we got an interest rate of 3%. So these are interest rates of 4 and 40. And this is 30%. So there it is again. That was pretty straightforward. The New York Volleyball Association. Okay, so this one is kind of tricky. You just got to kind of pay attention and see what's going on. Let's see what we got here. We're going to start with 64 teams. So 64 teams. And notice all of them start with 64 teams. That's the principal amount, or in this case, the starting number of teams. After each round, half of the teams are gone. This is really kind of like a half-life question, right? Because after each one, we're going to have 1/2 of the teams gone. How many of them have that? 64 1/2. That's negative 1/2. That's 1.5. And that's R. I don't even know why you'd put R there. And then, which equation represents the number of teams? T. So it's T equals. After R rounds. R. So let's say R was 1. Let's see if this makes sense. After round 1, that would be 32 teams playing 32 teams. That means you're going to have 32 winners and 32 not winners, otherwise known as losers, but they're gone. So you have 32 teams. So if I was to put 1 in here, I'd say, okay, 64 times 1/2 to the 1. Well, that's just half of 64, which would be 32, and that's this one right here, choice 4. So that was kind of tricky and kind of easy at the same time. Let's move on. The function blah, 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 is reflected in the y-axis. Okay, kids. So if I do this, let's say I have f of x equals, and it doesn't matter what it is, let's say it's negative x plus 3 squared. That's a reflection in the x-axis because it's outside the parentheses. But if I do this, that's a reflection over the y-axis. So it's on the inside of the parentheses. It's a reflection in the y-axis. So we're looking for something that has a negative on the inside of the parentheses or next to the graph. And let's see, this is the reflection over the x-axis. This is probably it right here. This would be the inverse. It's not a reflection. It's actually a reflection over the line y equals x. And this is just garbage. But let's say you weren't sure. What could you do? Oh, you could graph it. That's a great idea. Oh, sorry. I had to reboot my computer and I forgot to start my calculator. So we'll start it. I'll get back to it. Let's take a look at this next question. We'll start taking a look at it. This one's relatively straightforward. I'm not doing anything to the x. All I'm looking for this is a transformation. I'm not doing anything with the x. If I had, let's say, x plus 1 here, that would be a shift left or right 1. What I'm doing is I'm taking this and I'm really adding 2. To go from here to here, you're really adding 2 on the outside of the parentheses. And as we've talked before, adding on the outside of the parentheses is a shift up or down. It's a translation where you're adding 2 to the y value. Now, I know we haven't seen this notation in a while, but it is straight from your geometry. Translation, this is the answer right here, adding 2 to the y value. This is adding 1 to the y value. This is subtracting 1 from the y value and adding 1 to the x. This is subtracting 1 from the x, adding 1 to the y. Well, the only thing we did from here to here is add 2 on the outside. And remember, that's a shift up or down, which means it's a y shift. Okay? Let's go back to the calculator and take a look. So let me blow this up a little bit. Shouldn't use those terminology probably. But let me zoom in a little bit. And we'll go to graph mode, and let's see what we got. The original was 3 to the x. So I'll go 3 raised to the x and hit enter. And so you should expect that to be. Now, if I want the reflection over the y-axis, I should be looking for something like this, right? So I hit tab and do it on the same graph. And we said this was going to be 3 to the negative x. 3, where the heck am I going? Raised to the negative. Come on. 3 raised to the negative x. And you'll notice that it is clearly a reflection of the line y over the y-axis. So make sure you use your calculator as a tool. So you're not a tool. So this next question, quite frankly, you should be able to do without the use of a calculator. However, it would be great to look at and use the calculator, but this is an exponential function. Here it is, my exponential function. It's going to look something like this. It goes to the 0.20 or 0.1, excuse me, and it's going to go up. So remember that domain is how much does it go to the left and how much does it go to the right. Well, if I look here, it's going forever and ever left, forever and ever right. So that is all real numbers. Now, don't pick all integers, because if you picked all integers, you'd say, it could be 1, it could be 2, it could be 3, but it couldn't be 1.5. It's all real numbers. Now, I sort of tried to trick you a little bit, but I never asked you about the range. So let's talk about the range. Now, remember, the range is how much is it going up, how much is it going down. Let's see what goes up. We're going up to positive infinity, but down to and asymptotically approaching 0. So it goes from 0 to positive infinity. So if I asked you for the range would be from 0 to positive infinity. Notice it's not equal to 0. Another way to write this is x is greater than 0, which would have been, this choice except for not the greater than. Okay? Let's talk about this next one. I asked for a domain again on this one, but I may ask for range on the test. You never know. Yeah, we're almost done with the multiple choice. So let's see what we did here. If I graphed y equals 3 to the x, it would look like this. Go through the 0.10. But this thing went down 1. So really, it should go like this. It should have now a new asymptote at y equals 1, negative 1, right? Here's my y asymptote. And I'm going to draw this in purple. So now it'll go like this. Well, again, the domain, this is why I didn't like this question that much. I should have probably fixed it. The domain is forever and ever and ever left, forever and ever and ever right, which means it's from negative infinity to positive infinity. So let's talk about the range, just in case some evil teacher asked you about range someday. Well, the lowest y value is down here. Well, first of all, it goes forever and ever and ever to positive infinity. So how many of these go to positive infinity? Just a 2. And the lowest value it would be is down here at -1. So this would be from -1 to infinity. So this is actually the range, and this is actually the domain. Now, let's say you didn't know what that looked like. You say, okay, I don't really know. I'm not really sure what that looks like. So let me take a look at it. And I go, okay, that's 3 raised to the x, raised to the x. Now get out of exponent mode, -1. You got to make sure your -1 is there and not, see, notice the difference? -1. See how it's up in the air like this, and over here it's not up in the air? You got to make sure you're not up in the air like that if that's the way the problem was written. And I go 1, and there it is. There's my y-intercept. And if you don't know, just hit tab and hit -1. There's my asymptote. Now it looks like it hits it, but remember it doesn't hit it. It gets really close. You know, I can grab this. Let me grab this. You'll see that it's never going to hit it. It looks like it hits it, but you know, as you go over there, it doesn't hit it. All right. So that's that. Done with the multiple choice. A radioactive substance has a half-life. As soon as I see half-life right there, I know that my base is going to be 1/2. It has a half-life of 6,000 years. I don't know how much I'm starting with, but I know I got a half-life and I got a base of 6,000 years. If the original amount was 20 grams, oh, okay, so now I know what my original amount is. How much of the substance will be in the nearest tenth of a gram will remain after 1,200 years. So I want to know what my amount of will be. So if you just put T up here, then that would be taking a half-life 1,200 times. But remember, you got to get rid of, you're only taking a half-life every 6,000 years. So this is only 1,200 years. So I didn't even get close to a half-life. So I know my answer has to be greater than 10. Right? If I said, hey, how much remains after 6,000 years? And you put 6,000, you'd say, oh, 6,000 years, that's a half-life, that would be 10. This is only 1,200. In fact, it's got to be really close to 20 because it's not even like 1/6 of the way there. It's a little over 1/6 of the way there. And the way you do this is it's T divided by what is the half-life. In this case, the half-life is 6,000. So I just take 1,200 and plug it in here. So this was nothing more than understanding that you have to get rid of that fact that it's going to happen every 6,000 years. So you come over to your graphing calculator, go into calculator mode, and you go 20, parentheses. I just like using 0.5. It's a lot easier. Raised to the control division, 1,200. Now, I didn't really need those last 2 zeros. I could have just put 12 over 60 divided by 6,000. And it better be close to like maybe 18. Look at that, 17.411. And they want us to round this to the nearest tenth, so the answer is 17.4. Okay? Now, had you put in 1,200, so 20, parenthesis, 0.5, damn, I'm on it, 0.5, parenthesis, raised to the 1,200, you would find out you got like nothing. Right? E to the minus 360. That ain't make any sense. That's like 359 zeros and then that 1. Crazy. A bacteria doubles every 15 minutes. So here we go. Given that we start with 100 bacteria, so how much bacteria are we going to have? We're going to start with 100. We're going to double. That means we're going to double. Anytime you double something, that's your factor of growth. It could be a half, which means it's decay. It could be doubling. It could be a percentage. And we're doubling every 15 minutes. So what I got to do is first convert this to hours. So 4 times 60 equals 240. But it's not every minute, it's every 15 minutes. So you have to divide by 15. Now, if you wanted to, you could just do this, figure out what this is. 240 divided by 15, I think it's 16. And you get 16, and just type that in. And you can say, okay, I know it's going to be, what was it, 100? 100 bacteria, parenthesis, it's doubling, parenthesis, raised to the 16th power. Or you can put 240 divided by 15. It doesn't matter. It's a ginormous number. 6,556,553,600 bacteria after 4 hours. Ooh, that sounds like a big problem. So here's a problem I'm looking to see if you understand what all this stuff means. So housing over time is equal to 540, 1.039 to the t. And I said to you, what does the 540 represent? And what does the 1.039 present? Let's talk about this first. If you don't know what this means by now, really, truly get in and get some help. The number in front is the starting principal or initial amount. So in this case, we're going to start. It is the starting number of homes in Central Village, New York. The 1.039 is growth, is our growth factor. Now, how do I know it's growth and not decay? It's growth because it's bigger than 1. But it's not good enough to just tell me it's growth factor. You got to tell me what it's growing by. So again, I don't really care about the 1.09. I know I need that for growth. It's this thing I need. What is this as a percent? Well, I moved that decimal back over and I said, oh, and it is growing at 3.9%. Boom, done. All right, now this next one, if you didn't get the last one, get this one, okay? This represents the number of snowboarders in millions, and X represents the number of years since 1998. Explain what this and this means. So the 0.5 is, well, how about this? Represents, and it's kind of important that you say this, represents the 500,000 snowboarders in 1988. It's our starting number. Now, where did 500,000 came from? Remember, this is 0.5 in millions. So what does that mean? It means 500,000. Now, you could have written 500,000, or you could write 500,000. The 1.21 represents growth at a rate of 21% every year. Wow, that's huge. But I was just on the slopes the other day, and yeah, there's a lot of people on the slopes using snowboards. Kind of crazy. All right. A civil engineer firm suggests that a new, larger well must be built by the village to supply its water when the number of houses exceeds 1,000. Oh, I forgot these go together. So these two problems go together right here. So this has to do with this. All right, so we're going to use this formula. H of t equals 540 point, forgot the 1, 039 to the t. And so the question is, let's see if I can blow this up a little bit. The question is, when will it exceed 1,000 houses? So I want to know, when is this going to be 1,000? So I need to solve this very simple yet difficult equation until we got into this unit. So the first thing you got to do is get the weird thing alone. This is the weird thing. So we got to get this thing all by itself by getting rid of the 540. So we'll divide by 540. Divide by 540. So now I end up with 1.039 to the t equals 1,000 divided by 540. Now, whenever your variable is an exponent, whenever your variable is the exponent, you must use logarithms in order to solve it. And it's all about that base, about that base, about that base. So it's going to be log, here's our base, 1.039, of, now these two things switch sides, right? So of 1,000 over 540 is equal to t. Now let's see if we can make sense of this. In 1995, there were 540 homes. I want to know when it's going to be 1,000. And we're going by almost 4% a year growth. So, you know, I don't know, what's it going to take, 20 years maybe? I don't know. But if I come up with a number like 10,000, okay, 10,000, that doesn't even make any sense, okay? Maybe 10 years, maybe 15 years, maybe 20 years, but certainly not 10,000 years. So make sure your answer makes sense when you do it. So we're going to do log 1.039. Oops. 1.03. I cannot. This is weird. Sometimes my computer is not like that. So let me do it without my. So control log 1.039 of control division 1,000 all over 540. Enter. 16.157. So t is equal to 16.157. Where did it say to round to? During what year will this happen? Oh, wait a second. They want a year. Huh? Wait a second. Oh, wait, here we go. Started in 1995, and we're going up 16.51 years. So let me take that number and add 1995 and say, oh, okay, so it happened in 0.1, so sometime in 2011. So the answer here is 2011. So if you didn't understand that before, now try doing this problem, because this problem is basically the same. I forgot these go together too. Okay? So we're going to use that same formula, which is, what did I say? Did they give us a formula? Y in this case. Y is equal to 0.5 1.21 to the x. And they want to know, when will we have 10 million skateboarders? Well, now remember, x is in, or y is in millions, so I really don't want to put 10 million in here. I just want to put 10, because 10 represents 10 million. I'll show you what'll happen if you actually put 10 million in there. So 0.5, 1.21 to the x. Get the weird thing alone. Here's the weird thing again. So we got to get rid of that 0.5. So we'll divide by 0.5. So this gives me 20 is equal to 1.21 to the x. Again, whenever your variable is an x, or your variable is the exponent, you have to use log. So log, here's my base, 1.21 of 20 is equal to x. Now let's see what that makes. So log, control log 1.2, gosh blessed it, 1.21 of 20. 15 years. 15.7 years. So x equals 15.7 years. Now let's see if we can answer the question. Oh, what would happen if I put 20 in, or 20 million? So I have to take 20, 1, 2, 3, 1, 2, 3. There's 20 million divided by 0.5, divided by 0.5. And so now what I'd be doing is the logarithm of 4 million. Oops, I got an extra 0 in there. So I really am going to be doing the log 1.21 of Oh, excuse me. I should have taken half of 10 million, which would give me 20 million. 20? 1, 2, 3, 1, 2, 3. 20 million. Let's see how long it would take to get to 20 million. Oh, it would take 88 years. Ain't happening, kids. Ain't happening. So 15, I thought it was going to be bigger than that. 15.7, but the question says in what year, so you got to add 1988. So 1988 plus this number up here, and we get 2003 and some change. So it's 2003.7. It said in the year in which the number of snowboarders. Don't round this. The answer is 2003. Sometime during 2003, we got to 10 million snowboarders. By the way, in 88 years, they'll be having flying snowboards. So that 88 years wouldn't be a serious question, okay? Nothing better when you're going to do inverses. Nailed it again. All right, let's do some easier questions. We want to find inverses. Now, at first glance, you're like, what? But this isn't bad. First of all, do you understand that this is really y equals log base 10 of x? Right? Because I don't have to put the 10 here. It's understood to be there. All right, so how do you find an inverse? Well, the first thing you're going to do is, just like before, switch x and y. So you get x equals log base 10 of y. Well, I want to get y by itself. I need to get y by itself. If you have a log function and you want to solve for something, you have to use exponential. Right, exponential. Oh my God, you're so smart. You have to use exponential. And it's all about that base, about that base, about that base. Don't forget, it's all about the base. Gosh, I'm a great singer. So it's all about the base. There it is. So we're going to go 10. Now these two things switch. Remember, once you decide that you're going to go from logs to exponential, guess what you don't see in the equation? The word log. It goes away. It becomes an exponential function. So log. Oh, excuse me. We're going to turn this log. Where'd my pencil go? Okay. So we're going to base 10. Now these two things switch. 10 to the x is equal to y. Ka-ching, done. Problem's over with. Let's go. All right. What don't I have to tell you here? That's right. That this is an e. It's base e. So I want to find the inverse. So the first thing I'm going to do is switch x and y. X equals the natural log of y. Now, if you want to put this e in here, by all means, put the e in there. It's not wrong, but you don't need it there. So if it's a logarithm equation, I got to turn it into an exponential to solve. Oh, okay. And then we know it's all about the base. So e, that looks like an L, e, these two things switch to the x is equal to y. Now, if you don't know if you got this right, what's a great check? Oh, go to the calculator. That's right, Mr. Krause. You're so smart. So we'll come over here to our calculator, and I'm going to graph the natural log of x. There it is. Now, if I have the right equation, this should be a reflection over the line y equals x. Oh, maybe I should graph the line y equals x. There it is. There's the line y equals x. So my answer should be up here somewhere, and it should look like a mirror reflection of that if I have the right answer. So I'm going to type in tab e to the x. Oh, look at that. They look like mirror reflections of each other. I know I have it right. And had you done that for the other one, you'd be fine as well. Write the inverse of this. Now, this is an exponential. In order to solve this exponential, I'm going to have to use logs. But the first thing I got to do is switch the x and y. So let's switch the x and y. So I get x equals 5 to the y. I want to get y by itself, so I'm going to introduce logarithms. Log base 5, and then these two things switch, change a base. Log base 5 of x is equal to y. And again, if you don't believe me, let's press tab. Let's get, oops, escape. Tab. We'll get rid of this one. Oh, what the heck? Escape. And let's get rid of this. And let's get rid of this. And let's type in the original. The original was y equals 5 to the x. So 5 raised to the x. 5 raised to the x. There was the original. And we came up with log base 5 of x. So control, tab, control log base 5 of x. Now, if I did this correctly, they should look like mirror images across that thing, and they sure as heck do. Easy. There it is. So here's another way of saying, hey, find the inverse. Well, maybe the first thing I want to do is write it as y equals 9 to the 2x. Okay, this one's a wee bit trickier, but not much. Let's switch x and y. So x equals 9 to the 2y. This is an exponential. I need to turn it into a log. And it's all about that base. Should have gone into singing. I know, I'm amazing. So log, here's my base 9, and then these two things switch. Because logs are equal to exponents, so they need to switch. So log base 9 of what? X is equal to 2y. Well, I need to get y by itself, so I'll just divide by 2. So you can have one of two answers here. You can either have y equals, whoa, let's back up the crazy train, girlfriend. F inverse of x equals log base 9 of x over 2, or this is equivalent to 1/2 log base 9 of x. And again, you could graph that and verify that those are, in fact, the inverses of each other. All right, kids, let's highlight all the things that are important. Drew's parents started with initial balance of $1,500. It's going to double every 7 years. It's not doubling every year. It's doubling every 7 years. That's important. How many years to the nearest tenth of a year will it take to reach $1 million? Well, the first thing we got to do, kids, is come up with the bloody equation. So let's do that. Value over time is equal to our starting amount, which is $1,500. We're going to double it every 7 years. So normally I would just put time up here, but it's not every year, it's every 7 years. So you got to remember, oh yeah, I got to divide by 7. All right. So in for this, we're going to put in $1 million. So 1 million is equal to 1,500 to the t over 7. We have an exponential equation because my variable is an exponent. So in order to solve an exponential equation, I got to turn this thing into logarithms. Before I turn this thing into logarithms, you got to get the weird bloody thing alone. I don't know why people use bloody. The bloody thing. That's all like pirates. So we're going to divide by 1,500. Let me get rid of a couple zeros. I don't like these zeros. So now we got 2 to the t over 7 is equal to, what is that, 10,000? 1, 2, 3, yeah, over 15. I can leave it as a million over 1,500 if I wanted to. Now, this is an exponential function. I am going to now turn it into a log function. So log base 2, these two things switch sides, of 10,000 over 15 equals t over 7. Well, what's the last thing I got to do? I got to get rid of that 7, so I'm going to I'm going to multiply this side by 7, which means I got to multiply this side by 7. So in my calculator, there's what I want to type in. 7 times the log, don't remember what the base was, base 2 of 10,000 divided by 15. 65.665 years. So t equals 65.665 years. So I need to figure out what I want. Rounded to the nearest tenth of a year. So time is equal to 65.7 years to reach $1 million. Here we go. Bacteria grow by that formula. how about we use y equals 2t to the divided by 3. For what value of f of t equal to 32? So instead of y, why don't we just put in 32? The weird thing is already alone, so I can immediately turn this into logarithms. Log base 2 of 32 is equal to t over 3. Come back in, multiply both sides by 3. I go over to my calculator, to mein Taschenrechner. Now I multiply by 3 to get rid of these 3, by the way. I didn't really point that out, but to get rid of those 3. So 3 times the log base 2, of 32, 15. So t equals 15. All right, let's see what we got. All right, so what is the value of b in this equation? Notice that the bases are not the same. And I said when they're not the same, we need to make them the same. 2, 3, or 5, generally. Sometimes 7. You'll see we're probably going to use 7 soon. So this is 2 squared to the 2b minus 3 is equal to 2 cubed to the 1 minus b. So, once the bases are the same, I can set the exponents equal each other. What's that you just said? Oh my gosh, I broke my cardinal rule. Put the things in parentheses, otherwise you will have problems. So this is 2b minus 3 equals 3, 1 minus b. Now remember, this is what I'm putting in this thing right here. I don't care about these anymore. I could just get rid of them. All right, now I just got to solve it. 4b minus 12 is equal to 3 minus 3b. If I bring this over, I get 7b equals, add 12 here, I get something's wrong, kids. My number's wrong. Huh. Well, I'm going to check my answer because my answer here doesn't match the answer I put up on the answer key. So I got 15 here. So I get b equals 15 over 7. Now that doesn't match what I have on my written answer key. So that bothers me a little bit. So I probably should have checked these, but I like to make mistakes every once in a while. Let's see if I'm right. 15 divided by 7. And I'm going to store that into b. And the left side says 4 raised to the 2b minus 3. Silly number. 8 raised to the 1 minus b. Notice they're not the same. So I clearly made a mistake somewhere. And you know what? I didn't do this on purpose, but this is a great way to check to see if you got things right. I have no idea what I did wrong. I'm sure you guys are laughing at me right now. I will find it eventually. Oh. Man, where did that come from? All right, 2 times 3 is 6. So I'm going to add 6. So my answer is 9 over 7. Now let's check 9 over 7. Nine. Now, that's what I originally had. Let's go. Enter, enter. Enter, enter. There we go. Now notice that they match. Woo, got it right. Okay, I'm glad I found it. All right, I'll be back. Maybe I need some coffee. All right, so this one I changed. So a couple things. First of all, that's a 5. And I got rid of this. Sorry, that was supposed to be gone. All right, so there's my problem. Now, I said to you, if it's odd, make it 3. If it's even, make it 2. And if it's got a 5 in it, make it 5. But if you tried to, you'd say, oh, 49. That's not, I can't make that a 3. But I can make it a 7. So just because you see something weird doesn't mean you quit. Oh, isn't 49 really just 7 squared raised to the x squared plus, oh yeah, in parentheses, equals. And then if you come over to your calculator, you'd find out that 7 cubed is really 343 raised to the 5x over 3. Once I've done that, I just set these exponents equal to each other. That's it. That's all you do. 2x squared plus 1 equals 3 times 5x over 3. Well, the nice thing about that is these 3's cancel. So I get 2x squared plus 2 equals 5x. Subtract 5x, I get 2x squared minus 5x plus 2 equals 0. Let me factor this thing. 2x and x. We want to see when this makes this equal to 0. It means they're both going to be negative, and I can't put the 2 here, so 2's got to go here and the 1 here. So I get x equals 1/2 and x equals 2. Well, if I were you and you were a smart kid, you'd check these. So let me store a half into x. So 0.5, store it into x, and I want to type in 49 raised to the x squared plus 1. Some dumb number. And now 343 raised to the 5x over 3. Control division 5x divided by 3. Oops. Over 3. Oh, same dumb number. Got it. But I should check 2 too. Sometimes they may not work. So I'm going to do 2. Control var x. Once you check the first one, the second one's easy to check. Just get up. There it is. Ding, ding. You get some. Ooh, man. Looks like my salary. There we go. My salary squared. Bye. Ooh, here we go. What are the domain and range of this? Okay. So this is actually not a bad problem. I'm not going to use the graphing calculator, but I would highly suggest you do. Actually, I might do one of them just to show you. But don't all log functions go through the point 1, 0? So that's what a log function should look like. But this one moved right 4 units. So it's not there. It moved to the 4. 1, 2, 3, 4. It moved right 4 units. So now it goes to the point 50, and what's my asymptote here? My asymptote here is x equals 1, 2, 3, 4. Oh, isn't that weird? This is my asymptote. So if I want domain, you can write it any way you want. It's either x is greater than 4, or you can write 4 to infinity. And range is really easy. Range, it goes forever and ever down, forever and ever up. So that would just be all reals. Or you can write either all real numbers or negative infinity to positive infinity. Now, just so you know, we can graph this and take a look to see what it looks like. So you do control log, what are we doing? Base 2 of x minus 4. Boom, there it is. Now, if you don't know what this asymptote is, hit tab, hit the delete button, and go into relation, and you're going to type in x equals 4. And there's the line x equals 4, and you'll notice that it is a asymptote. Okay. Next one I will not graph. What are the domain and range of this? Okay, so this one we are going to graph. I apologize. Yes, we are. This one's a funky one. Notice the negative is on the inside. That means it's a reflection in the y-axis. So that although we think we're going to move to the, well, I don't know, this looks like we're moving to the right. I don't know. Well, wait, this is a plus 8, so that means we looks kind of like we're moving to the left 8, but we really move to the right 8 because to reflect. Well, let's just graph it. If you don't know, graph it. It's not going to hurt you. So you graph log base 3 of 8 minus x. Oh, okay. Now it's a log function that's going in the other direction because it was an inverse. It was a reflection in the y-axis. So it looks like 1, 2, 3, 4, 5, 6, 7, 8. There's my vertical asymptote again. And yes, it's what's right here, minus 8. So my vertical asymptote is 8. So it's going to look something like this, where this is the line x equals 8. So if I wanted to write my domain would be negative infinity all the way up to, but not including 8. Range is easy. Range for logs are easy. It's negative infinity to positive infinity. It goes forever and ever down, forever and ever up. All right, let's keep moving and grooving and shaking and baking. A lot of words here. Sean invests 10 grand at an annual interest rate of 5%. So there's my initial amount, my starting amount. Oh, okay. They were nice. Because it's continuous, I have to use PERT, right? So I have to use my accrued amount is equal to my principal, E, to the rate times time. So let's see. That's 10,000 is equal to, not 10,000 is equal to, 10,000 is my principal amount. 10,000 E, what's my rate? 5%, 0.05. Determine how many years. So I don't know how many years. So I'm going to put T in here. For my amount to double. Okay. So I know if it's going to double, then shouldn't that be $20,000? I want to know how long it's going to take before my money doubles is equal to $10,000. E to the 0.05 T. So they didn't tell you that it was $20,000. They just said my amount's going to double. And so you got to be careful the way you read it. But the math is the same. We got to get the weird thing alone. Divide by 10,000. Divide by 10,000. And you get 2 is equal to E to the 0.05 T. Okay, this is an exponential function. It is the natural base E, so we have to use the natural logs. This is the one time when you got an E and you got a variable that's an exponent that you have to use natural logs. So it's all about the base. So it's going to be the natural log of base E. These two things switch of 2 is equal to 0.05 times T. Well, we still got to get T by itself, so we divide by 0.05. And that'll tell me what my T value is. So I go back to my calculator, and I go control division, the natural log. Now notice it doesn't allow you to put in the E. You just have to understand it's there, of 2 divided by 0.05. And it's going to take me 13.86 years. 13.86 years. Determine how many years to the nearest year. So T equals 14. All right, you should be able to do this one. You should have been able to do this one because I just did a couple up here. I did some harder ones up here, so you should be able to do this one. This has a base of 81. It's odd, so I'm probably going to turn it into 3. First thing I'm going to do, of course, is put parentheses around this. As Miss Newman would say and annoy her students, parentheses, Patrice! Ooh, I was channeling my intern, Newman. And her creepy hands. Anyway, 81 is 3 to the 4th. Now, let's say you're saying, how do you know that, Mr. Krause? I would never know that. Oh, really? Just go 3 to the 4th. Oh, yeah, it's 81. I see that. 27. Oh, wait, hold on. X plus 2 is equal to 27 is 3 cubed to the 5x plus 4. Once the bases are the same, sorry. Yes. All right, once the base are the same, we set the exponents equal to each other. Not this. Don't need this. So 4x plus 2 is equal to 5x plus 4. Distribute 4x plus 8 equals 15x plus 12. Let's see. I'm going to bring those over. So this gives me 11x equals negative 4. I'm assuming I didn't have to show you how I subtracted 4x, subtracted 11 or 12, subtracted 12. So divide by 11 and I get x equals negative 4 over 11. I suggest you check this, but I'm not going to. I ain't got time for that stuff. Let's do another one. Parentheses. This one is even, so I'm going to change them all to 2. I could use 4 in this case. 2 is easier. It's just easier. So 2, I don't know, maybe it's 2 to the 5th, 2 to the 6th. Let's see, 2 to the 5th. That's 32. That ain't it. 2 to the 6th. There it is, 64. So 2 to the 6th to the x plus x minus 2 is equal to 2 to the who in the heck knows. Let's go 2 to the, 8th. I got lucky. 2 to the 8th. I'm just kidding. I knew that. 2 to the 8th to the 2x. So, set the exponents equal to each other. There they are. So I get 6. X minus 2 is equal to 16x. Just set the exponents equal. So we got to solve it. 6x minus 12 is equal to 16x. Divide by, or excuse me, we got to subtract 6x here. Minus 6x, minus 6x. So I get negative, be careful, don't forget to copy down that negative. Negative 12 is equal to 10x. Divide by 10, and we get x equals negative 6 over 5. If you reduce it, you could leave it as negative 12 over 10. Check it, make sure it works. Oh my god, this problem is way too difficult for 11th and 9th and 10th graders and all you smart kids. Can't do it. Not gonna do it. Wait. Hold on. You mean it's just a log function? And if I have a log function, I just turn it into an exponential? And then it's pretty easy? Okay, let's ignore this right now, because that's the confusing part. You're like, well, I don't understand. What do I do? Plug that in? Do I do f of negative 2? I don't know. Just find x. Go with things you know. If you have a log function, you solve it using an exponential. If you have an exponential function, you solve it using log functions. And it's all about that base, Oh, yes. Megan Trainor ain't got nothing on me. And that just caused my dogs to go crazy. Especially my little one, who's not the smartest one in the world. Ooh, mean eyes from the wife. All right, here we go. It's all about that base. So the base is 5, and then these two things switch. 5 squared is equal to x, so x is equal to 25. So, wait, let's go back. What's the question? What is the square root of x? So wouldn't that just be the square root of 25, which would just be 5? Oh my god, it was that easy and stuff. Let's go. All right, here we go. 29. Only 2 pages left, kids, and we're like an hour into this thing. All right. Again, it's all about that base, so we'll just go flying through it. Base 2 cubed is equal to x plus 1. That's 8 is equal to x plus 1. I'm assuming you guys can figure out that x equals 7. Yeah, and check it. Here we go. 8 to the 2/3 power. It's all about that base. 8, these two things switch. This becomes the exponent. 2/3 equals x plus 1. If you put that in your calculator, 8 to the 2/3. Now remind me, wait a second, base, or the denominator is the exponent. The denominator is the root, because they're in the ground, and the 2 is the exponent. So the cube root of 8 is 2, 2 squared is 4. Or you can type in your calculator, 4 equals x plus 1. So x is equal to 3. Oh yeah, check your answers. Here we go. This one's kind of tricky. So it's a logarithm. We're going to solve it by using exponential. So I get x raised to the negative 2 is equal to 9. Well, that doesn't help out. And if you divide by negative 2, I might come by and pour my coffee on your head. Unless it's Dunkin' Donuts, and then I'll drink it. And then I'll just not pour anything on your head. I don't know where that. So how do I get rid of it? So I got to get rid of the negative 2. How do I get rid of it? Oh yeah, raise it to the reciprocal, negative 1/2. Raise this side to the reciprocal, negative 1/2. Oh, these cancel. I get x equals, and if you type this in, you'd end up with 1/3. Now, why 1/3? Well, the negative says, take it, put it in the denominator, so we'll leave 1 in the numerator, and you get 9 to the 1/2 power. Oh, and 1/2 is just square root. 32. The relationship between the relative size of an earthquake S and the measure of the earthquake on the Richter scale R is given by the equation log S equals R. What's my base here? What's my base? That's right, base 10. If an earthquake measured 32 on the Richter scale, what was the relative size? So I'm looking for S. So it's log base 10 of size is equal to 3.2. This is a log function. In order to solve it, I must use exponential. So 10, these two things switch to the 3.2 is equal to S. And just because I don't want to type this in my calculator, because this is taking way too long, I typed that in my calculator. What the heck, let's type it. Okay, maybe. $10 raised to the 3.2. There it is, 1584.89. It tells us to round to the nearest hundredth. 1584.89. So 1584.89. Ka-ching. So this one's got two parts in it. Whatever this person's name is bought a Chevy Trax in August of 2016. The cost of the car was $26,458. I think that looks like Mrs. Newman's car. But she traded in her Saturn. Oh, this is not an easy question. Pay attention. But she traded in her Saturn for this is Mrs. Newman, and she got $2,300 for her Saturn as a down payment. So if this is what the car cost, and this was my down payment, that's not how much I have to take a loan out for. Let me figure out what my loan is going to be. Let me figure out what my loan amount is going to be. My loan amount will be, if I don't take those and subtract them, so 26,458 minus 2,300. 24,158. So my loan amount is going to be 24,158. All right. Determine the, oh, wait a second. Alert, alert, alert. We're going to mess with you. This is a percentage. You need to convert that to a decimal. That's going to be key to getting these right. I'm going to show you what would happen if you don't get this right so that it doesn't happen to you, okay? So let's see. First thing I'm going to do is turn it in 0.375. Just a reminder, divided by 100, it really just moves the decimal place over twice, but it's really 0.00375. So this is really 0.00375. Okay. Determine the monthly payment on a 6-year loan. Oh my God, there's so much going on. 6 years is 72 months. We had a lot to do in this problem, but I think we're okay now. So, this is part B, but the only place I gave you room is to do it down here. So let's do it down here. $24,158 is equal to my payment. There was a T here. My payment, and then all this crap. 1 minus 1 plus I to the negative 72 over I. Oh, wait. I know, don't I? I know I. I is not the variable I. In this case, I is the interest rate. So let me put that in there. 0.00375. 0.00375. Okay. So I'll probably just want to figure out what the heck this is. So I'm going to come over to my calculator. Let's do control. Let me get a fresh one. So control division. And then it's going to be 1 minus parenthesis 1 plus 0.00375 parenthesis raised to the negative 72 all over 0.00375. Enter. Now that's the number I get. Now, what I have here now is 24,158 equals my payment times 62.99. Don't round early. 5976. Close enough. Because all I need is 2 decimals. So what I'm going to do is take 24,158 and I'm going to divide it by this. And I get 383.48. So my payment is going to be 383.48. Now notice it didn't tell you where to round, so that's my monthly payment. Now, what would have happened if I screwed up and used 0.375? Let's go back up here and use 0.375. So what we're going to do is we're going to get rid of these and see how that changes the problem. It's going to change it drastically. So now we're going to take my my $24,158 car, and I'm going to divide it by this. Now, let's see if this makes sense for my monthly payment. Oh, I've got to pay $9,000 a month for a car. For 6 years? 72 months, you're going to pay $9,000 a month? It's like $1 million car. Okay, so that doesn't make sense. So just make sure your answer makes sense when you're done. All right, now let's do part B. Part B, again, I didn't leave you a lot of room and I apologize. Now I want to make a monthly payment of $400. And I know I didn't leave you a lot of room here. So now I want to make a monthly payment of $400. So I need to know what my down payment should be. How many months would it take to pay off if she paid $400 a month instead? I apologize. This is a different problem. So we know our payment. What we don't know is the number of months. So 1 minus 1 plus 0.00375 to the negative n all over 0.00375. Now, at first glance, I got to solve for that little tiny n that's sitting right there, and you're probably saying to yourself, what? How in the world am I going to solve for that little tiny n right there? What the heck? All right, let's start by doing the normal thing. Get the weird thing alone. Let's get the weird thing alone. So we're going to divide by 400. All I want to do is figure out how many months this is going to take. So, okay. So now I've got, I don't know, let's see. I don't know if so I got 20, maybe I want to put that in my calculator. 24,158 divided by 400. Maybe it'll give me a nicer number to look like. 60.395. Okay, that's easy to deal with. 60.395 equals this freaking mess. 1 minus 1 plus, well, can I write this as just 1.0336? I think I can write this 1.00375 to the negative n all over 0.00375. Well, now what am I going to do? Oh, I'm going to cross multiply. So I'm going to take this number and I'm going to multiply it by 0.00375. Now I'm going to get some silly small number, 0.22648. So 0.22648, 125. Like, don't round, is equal to 1 minus 1.00375 to the negative n. I'm almost done, believe it or not. Let me subtract 1. Subtract 1, so minus 1. So now I've got negative 0.7735 1875 equals 1.00375 to the negative n. Woo! Yes! All right, kids, we're almost done. I have an exponential function. In order to solve an exponential function, I have to use logarithms. So, let me change it. It's going to be log base 1, what happened to my 375? 375. 1.00375 of negative 0.77351875 is equal to, now be careful here, it's equal to negative n because your answer is going to turn out to be negative. So log 1.00375 of this, enter, oops, can't take the log of a negative number. Oh, shoot, I missed something. Sorry, kids. See, this is a negative right here, right? So it's negative. See how the minus is right here? I forgot that. So I got to divide by a negative, so that makes this positive. So this should be positive. Can't take the log of a negative number. I know that. And we get negative 68.6. So negative n is equal to negative 68.609. And so n is equal to 69 months. It said round to the nearest month. That makes sense, right? It was 72 months. Now it's 69 months because you're paying more per month. Woo, that was a brutal question. Well, we're getting close, kids. We are getting close. Let's see. This girl skipped rocks across flat water, rippled a diameter of 8 inches. Each skip after that created a circle with 1/4 the size. So 1/4 is your scale factor. In this case, it's going down, so it's decay, right? So we're going to start with A. Well, diameter and what do you call them? Jumps? Skips. The diameter skips is equal to, we started with a diameter of 8. It's going to go down by 1/4 every skip. Write an explicit rule to represent the situation. There it is. Well, wait a second. That means on, does that make sense? After the first skip, it should be 2. I guess this should be -1. Because the first skip was 8. So if you don't do this, right, and you put a 1 in there, on that first skip, that ripple should be 8. And if you don't put a -1, then you're really going to the second skip. So that's that one. Write the recursive rule. Okay. A sub 1 is equal to 8. A sub n is equal to 1/4 times a sub n minus 1. Believe it or not, that's it. All right, simplify. Well, first of all, anything to the 0 power is 1. So this becomes 1/27 to the 2/3 power. Now, when we have exponents raised to exponents, we multiply them. Well, 1 to any power is just 1. So this becomes 1/27 to the negative 2/3. Well, wait a second. That is negative, so it comes up because it's got a negative exponent. So it really becomes 27 to the 2/3 power. And if you type that in your calculator, believe it or not, the answer is 9. It's kind of a silly question. This one's just as silly. What kind of a regression are we going to use? Well, you'll notice it sort of looks like this, and we should be using logarithmic. Pretty easy there. All right, so this one's not so easy. So it's not bad. It's just not that easy. So what we're going to do is you're going to divide. So 3 goes into 6 twice. Now, when you're dividing and you have exponents, you have to subtract the exponents. So x over x to the 1/2. This is really a 1 over here. So you subtract the exponents. You get 1/2. So far we're going to start with 2x to the 1/2. If I subtract these 3/4 minus 1/2 is 1/4. So y to the 1/4. Now, how can you check this? Well, you can store like a number like 2.3 into x and 5.7 into y. Type in the original, type in this, and they should arrive at the same solution. I'm not going to take the time to do that. What happens to exponents when we multiply? Well, when we multiply, we add the exponents. So this should be negative 18, x to the negative 1, y to the 7, z to the negative 1. But write your answer only using positive exponents. Okay. This is really over 1. So what happens? Well, this, because it's negative, has to come down here, and this, because it's negative, has to come down here. And when they move, they get changed in exponents. So this is really equal to negative 18 y to the 7th, and the x and the z come down. All right, let me start with a fresh. Okay, what is she storing? Black bean and sweet potato chili. I can't even smell or taste, but that doesn't sound good. Actually, kind of sounds good. I don't know if it sounds good or it sounds gross. Now I'm getting hungry, and it's 12 o'clock, so I think it's lunchtime, so whatever. So here we go. Miss Newman storing leftover black bean and sweet potato chili in the freezer. The table below shows the chili's temperature in degrees Fahrenheit after T minutes in the freezer. Write a model to represent the data, rounding all answers to coefficients to the nearest tens. So is it linear? Is it exponential? Is it is it logarithmic? Is it cubic? What kind of regression is this? Is it quartic? We did our last test, we did quartic. I don't know what this is. It looks like it's going down. It looks like decay. So to me, as by looking at it, it might be exponential decay, but I'm not sure. So in order to save time, what I did was I typed in the values. But I need to take a look at it. So I'm going to come over here and click Doc, Insert, Data and Statistics. I will not share that with you. Doc, Insert, Data and Statistics. Click this. On the bottom goes time. And on the top goes Fahrenheit, temperature. Oh, that's clearly exponential decay. Clearly it's exponential decay. So I come back over here and I say, okay, menu, statistics, data calculations, and we're going to do exponential regression, not logarithmic. If I was doing logarithmic, it'd be right here. We're going to do exponential regression, T and F. All right. There's my equation. Y equals A times B to the X. Yes, if you forget the Y, you lose points. Y equals A times, and I'm putting this in parentheses, B to the X. A is equal to 98.24196. 98.24196. That's way past what they rounded. 0.968. 0.968. 6633. 6633. And I need to round all to the nearest thousandths. So I'm going to write my equation. Y equals 98.242 0.969 to the X. Now, if I'm asking another question, I might ask another question. I might say, how long before the temperature, and by the way, this should be f of t, not y, f of t. How long before the temperature is, or how many minutes would it take for the temperature to reach 24 degrees? What if I said I want the Fahrenheit to be 24 degrees? Well, okay, that's not bad. What we're going to do is I would just put 24 in here, and I probably will ask an extra question like this. Now notice I'm giving you Fahrenheit. If I just gave you time, and I said, oh, okay, after 45 minutes, I would just plug 45 into here. But that's not the case. I'm giving you the temperature. This is the harder problem. 98.242. And I said, how long before it reaches 24 degrees to the nearest tenth of a minute? All right, so 0.969 to the X. All right, so I divide by 98.242, because you got to get the weird thing alone, 98.242. Go to my calculator, and I take 24, and I'm going to divide by 98.242. All right, I get that obnoxious number. So I get 0.969 to the x equals, I'm just going to leave this as 24.98.242. So now it's all about that base, Log, because I have an exponential, base 0.969 of 24 over 98.242 equals x. So hopefully it turns out it's 24 is right about here, so it should turn out to be about 45 minutes, around. So control log base 0.969 of 24 divided by 98.242 equals 44.75, 44.8. So my answer should be x equals 44.8, and that should make sense. It's right there in the middle. All right, so we're almost done. New York State has an average cost tuition to college fund. Oh, I should pause this. All right, so here we go. We got to talk, what is it, 529 plan? New York State has the average cost of tuition of college of 2016 to 2017 of $33,000. So that's what it's going to cost. It's projected after the next 10 years that it will increase by, all right, 6%. We want to write an explicit rule. So how about cost over time? How about C of t, I don't think I put this in my answer key, is equal to, we're going to starting value, we're going to do an explicit rule, 33,480. It's going to increase, so this is exponential growth, 1.06. And if I just put t here, would that be acceptable? Well, that means on the first year that it would be this. But no, I don't want that. I want that first year to it just to be, so I'm going to do t minus 1. So that first year would just be 33,480. So now the recursive rule says a sub 1 is equal to 33,480. Now this is a sub n. It's real simple, kids. 1.06 times a sub n minus 1. Remember, the recursive rule is always doing something to the previous term. All right, kids. These two look really, really awful. But believe it or not, they're actually quite simple. Very, very simple. So let's say I just said solve for y. All right, the way it's written right now, that's way too crazy. So what I'm going to do is I'm going to convert them. X to the 4/3 power. Now, how did I get 4/3? Remember, roots are in the ground. This is the root. It goes in the denominator. And this is my exponent. Right? So if I cross this off, I would just have x to the 4th. So if I'm going to do that same thing to this side, y to the 3/7. Okay, that's the first step. Now, how do I get y by itself? I need to solve for y, so I need to get rid of this 3/7. So I'm going to raise it to the reciprocal, 7/3. So if I raise that side to the reciprocal, I got to raise this side to the 7/3 as well. So these cancel, 3's cancel, 7's cancel. I end up with y equals x to the, now nothing cancels here, so it's just multiply numerators, multiply denominators. 28 over 9. That's it. Kind of a dumb question. All right, so now I'm asking you to solve for y. This one's a little bit trickier because you got to get y by itself. But I think even still beforehand, I'm going to convert these things to their rational exponents. X to the 5/3 equals y to the 5/3. All right, so I want to get x by itself, or y by itself, so I'm going to divide by this y squared. When you divide, you subtract the exponent. So I can come over to my calculator if I need to. 5 divided by 3 minus 2. Oh. Now, if you did that on the normal calculus, I don't know why it's doing this. Settings, document settings, approximate. I want it on auto. Make default, click OK. So if I come back up here, And I do this again, it's the negative 1/3. So what I end up with is x to the 5/3 is equal to y to the negative 1/3. You really want to make sure you have that rational exponent, because now to get rid of it, I raise it to the reciprocal, which is negative 3/1. Negative 3/1. So these go. So I end up with y equals, what happens here? The 3's cancel. I end up with y equals x to the negative 5. But I think the direction said right without negative exponents. So what I got to do now is I got to say, okay, y is equal to, remember this is really over 1, so since it's negative, it's got to come down here, 1 over x to the 5th. They're really not that bad. The first thing you got to do is remember to turn them into their rational exponents and then just raise them to the reciprocal. Don't multiply them, raise them to the reciprocal. And that's it. There she goes. Well, like a 2-hour practice test. All right, that's it. Keep studying, kids. Keep working hard. You're almost done. We're almost on break.